Hello students, once again welcome you all in my YouTube channel Pacific Chemistry Classes. If you have not subscribed my channel, do subscribe the channel. Students, today I am going to explain the important Mitsunobu reaction, which is very important for our NET exam as well as our MSc topic. So I hope you have watched my previous video. So let us start our today's topic, that is our Mitsunobu reaction. Students, this reaction is reported by Oyo Mitsunobu in 1967 at IOAM Gakuin University in Tokyo. And this reaction, what is the main important thing in this reaction? In this reaction, they allows the conversion of primary and secondary alcohol to the esters, thioethers, phenyl ethers, etc. So here I have taken one example. In this reaction, what happens? This reaction, our alcohol reacts with the acids, and this acids and alcohol react to form the esters, है ना, कोई भी हमारा byproducts they will form. So here what are the important thing? Here the important reagents are our DEAD, that is our diethyl azo-dicarboxylate, and our triphenyl phosphine PPH3. So this is the overall reactions when we have taken our alcohol and our acids, so they will get converted to our ester. And the important thing in this reaction is that these reactions proceed through the SN2 mechanism. SN2 mechanism, what is important in SN2 mechanism? That the inversion of the configuration takes place. Means what happens here? If suppose our OH is in plane, so it will get the product will have the out of the plane, any product will form, ester will form, so this group will be out of the plane. What is the inversion of configuration? You can see better in this example. So if suppose we have taken an alcohol and we have taken an acid, so here I have written it in the form of NuH. So we can say that if suppose it is any acids like C6H5COOH, so it will have the two parts. So what it will have, we can write it in this way, na? C6H5COO minus and H plus ionization. Then, so this is our nucleophile part, means it is having the minus charge, and H will have the positive charge. So in this reaction, basically what we have to remember, that this reactions takes place with any conjugate base of any acid. So he will write it in the form of NuH, because we need Nu, means we need the conjugate base of any acid. So here when we react any alcohol with conjugate base of any acid in the presence of our reagent, that is our DAD, diethyl azo-dicarboxylate, and triphenyl phosphines, alcohols gets converted to our respective product, and the product is our SN2. What is the important thing in SN2? Important thing in the SN2 is the inversion of the configuration takes place. Inversion of the configuration means if suppose your all the umbrella opens in the, suppose it is opening in the left direction, so the product, all the functional group will present on the right direction. Inversion ho jayega na, reverse. So just the important thing you have to remember in this reaction is that this reaction we are using the two important reagent, that is the PPH3 and our DAD. So if we see the structure of our DAD, so how we can write? Diethyl means C2H5 COO and double bond and COO C2H5. This is our diethyl azo-dicarboxylate structure. We can also write this structure in this manner. ETO2 means ester group we have to remember na, COO C2H5 and double bond N. So this N double bond N, what is this N double bond N? It is our azo group, diazo. You know benzene diazonium chloride. What is the formula? C6H5N2 Cl. Generally we studied the diazonium group first in this compound. Okay, so this is our diethyl, 2-ethyl group, diethyl azo means this group, dicarboxylate. C6 any group can be there, dicarboxylate. So here it is our C2H5COO. So okay, now what we can write in this reaction? Alcohol becomes the electrophile and the nucleophile is the conjugate base of any carboxylic acid. I hope this sentence is clear. Conjugate base of any carboxylic acid. Conjugate base of any carboxylic acid means here the nucleophile will be our anion of any acid. Okay, so you can write it down. Now the other important points of this reaction, So, and this step, you can see what you have to write in the introduction part. In this reaction, we are taking any alcohol, either primary or secondary, they will react with the acid, or you can write the conjugate base of an acid in the presence of our DAD or PPH3 to give a ester or any other respective product like thioethers, phenyl ethers, etc. So, in this reaction, alcohol and carboxylic acid reacts in the presence of DAD and triphenyl phosphine to give the corresponding ester, and the product will takes by the Walden inversion. Already up SN2 you have studied in the detail. Walden inversion is the inversion of our our configuration. So what I will cover the introduction, reaction mechanism and application in this video. So please do now note this important point. The reaction will proceed with the inversion of the configuration. The reaction proceed under the mild, mostly neutral conditions, typically at our 0 degree to room temperature, means we don't need much temperature, and this conditions provides very high yields, and this is very good for our unhindered alcohols, and the alcohols becomes as an electrophile and the nucleophile is our relatively weak conjugate base. So students, we will start the mechanism of this reaction by taking our this simplest reaction. So you can one or two reactions you can write in the introduction. So mechanism, we will start with our this reaction. So what is this? This is our alcohol and it is reacting with the any acid, and we have written it in the form of HNU. It's nucleophile plus H, and the reactions give the product as the SN2, means our inversion of the configuration. OH is in the right side here, it will here in the left side. So I hope this is clear. So okay, so this reaction will takes place in the 4 step. So now let us see our first step. Okay, so we have taken triphenyl phosphine as our one of the reagent and DAD as a second reagent. So first step, what will happen? This our triphenyl phosphine, it will add to the nitrogen bond. Nitrogen double bond is very weak bond. So this electron will attack on the nitrogen pi bond. So what happens here? These electrons will move here. So the valency of nitrogen will get disturbed and this pi bond will move on this nitrogen. So what happens in this structure? This nitrogen will acquire the negative charge, and as this phosphorus is giving the electron to the nitrogen, it will acquire the positive charge. So you can pen down in the first step. What happens? Our PPH3 adds to the weak nitrogen pi bond to give an anion which will stabilize itself afterwards by the ester group. In the first step, you can see once again, first the attack of our PPH3 will takes place on the nitrogen bond, that is our weak pi bond. So it will get we will get an anion and we will have the positive charge on the phosphorus species. Then this anion will get stabilized by the oxygen of our ester group. So you can easily note down the points. I hope the first step is clear. First step is the attack of our PPH3 will add to the anion bond and it will give an anion which will get stabilized by the ester group. So what happens here? This anion is formed and this anion nitrogen will have the negative charge here. Again, it has to get stabilized. So what will happen? It will move the negative charge further here. So here one bond will form between the nitrogen and the carbon. This is the carbon of ester group, COO. Excuse me. So this electron will move on the oxygen. So the oxygen will acquire the negative charge. So here we will see they can get interchange into each other. Okay, so second step, we will start with this anion. Okay, so here we will have one anion stabilized by the ester group. So the negative charge will transfer on the oxygen. So now we will see our second step. So now we will see the second step. So second step, what happens here? Second step is the deprotonation of our nucleophile. So as we have seen now, we are taking HNU or NUH. So what happens here in the second step? Our this nucleophile proton will be taken away by this anion. So what happens here? When this nucleophile and this H approaches towards this our anion, means we have seen in the first step this anion species is formed. Now what happens here in the second step? this intermediate will deprotonate the nucleophile. It will take the proton and here the hydrogen will get attached. So what happens here? Simple, this hydrogen will get attached and this nitrogen minus charge will be neutral by this H plus, and so here minus charge will go on. So as we have seen now, if we see any our acid and its parts, ionized parts, so this will have nucleophile will have the negative charge and H will have the positive charge. Okay, nucleophile means nucleus loving negative charge species, electrophile will have the positive charge. So here in the second step, what happens? This nucleophile will be relieved for the attack on the alcohol. So you can write it down. The intermediate nitrogen anion formed, it will deprotonate the nucleophile. The nucleophile released is ready for the attack, and our nucleophile is added as a conjugate acid of our HNU. Means we will take the it acts as a conjugate acid, means HNU is an acid acting as a conjugate acid here, and its conjugate base is our benzoate ion. So now we will see our third step. So third step starts with the attack on the positive phosphorus by the alcohol. So in the third step I will explain the three parts. First, A part, what happens here? This positively charged phosphorus is having a strong affinity for the oxygen, because we know that there are the lone pair of electrons and here is the positive charge. So definitely this phosphorus will be attacked by the oxygen and they will form one bond, and so we will have a electrophile species, that is ROH PPH3. So what happens here? This PPH3 will get attached. So when this PPH3 will get detached from here, this nitrogen will gain the negative charge again. So we are having the second nitrogen anion ready, okay, in this reaction. So first part, alcohol will attack, and second part, what happens here? This proton which is removed by this second nitrogen, what will happen? This second nitrogen anion will remove the proton from the alcohol and it will give electrophile ROPPH3. So when this H will be removed, so electrophile species is formed and our reduced form of the diode is also formed. Why this reduced form? Because in the beginning we had seen there are two double bonds present in between these two nitrogen. Now here when this hydrogen is also detached here, so it will have like this structure. So this is the reduced form of our DED. Okay, so this will be the third step. What is the third step? Third step, first the alcohol will attack our positively phosphorus PPH3. So what happens here? We will have the positive charge on oxygen as well as phosphorus, and then this is the B part. So here the anion which is formed here, as this electron moves on the nitrogen, so the negative charge develops. So what we will say, this is the second nitrogen anion, and second nitrogen anion, what will he do? This will abstract this hydrogen again, this electron will move and this oxygen will be the neutral, and it will get stabilized. But this species is known as our electrophilic species, as this is having the positive charge. So this will go for the fourth step, and this will get hydrogen and it will get the reduced form of our DED. How this will have the reduced form? As our double bond, as having both the hydrogens attached with the nitrogens by removing the. So now fourth step, we can say that fourth step, the nucleophile which is formed in our second step will attack the alcohol. Nucleophile will attack the phosphorus derivative, or electrophile we can say, of the alcohol by the SN2. SN2 means it will get attached to that part from where the OH is removed. So now we can see that here it will form the inverse product configuration. Means in the beginning what we have seen, our OH is on the, where OH was present, it is present on the right hand side. So now when NU will come, it will get attached to the left hand side. So this is all for our reaction. I hope the reaction is clear. Now let us revise quickly. First, what happens? Our alcohol, the OH group is present on the right hand side, but the reaction as it proceeds by the SN2 mode, the product will form, the nucleophile will get attached on the left hand side. So first step, what is the first step you have to write? In the first step, the phosphine adds to the weak nitrogen bond and it will get our form given anion which is stabilized by the ester group. Okay, so what is the second step? Second step will be the deprotonation of the nucleophile. So here our nucleophile will H bond, H will be get attached to this nitrogen, and we will have our this nucleophile relief for the attack in the fourth step. So third step, what will happen? The anion which is formed in the, just a minute. In the third step, the alcohol OH group will attack the our phosphorus positive charge. So what happens here? We will have the formation of an electrophilic species, and we will have the reduced form of the dead. And in the fourth step, finally the nucleophile and the electrophile will undergo the reaction, and we will get the desired product, and the phosphine oxide will be eliminated as the byproduct. So the two important byproduct of these reactions will be our phosphine molecule as well as our reduced form of the dead and our SN2 product. Okay, so just you can see this, all the steps I have written here. So first step, I hope it is very clear. Phosphine will attack on the dead, then we have anion, it will get stabilized by the ester group, and again we will start the second reaction by the anion. This anion will abstract the proton of our conjugate this carboxylic acid, and we will have a positively charged species derivative, and our nucleophile is released. In the third step, what happens? This OH oxygen will attack on the positive charge which is formed in the second step, and this will ROH PPH3 positive species oxyphosphonium ion will form, and in the last क्या होगा आपका? This hydrogen will be abstracted by the anion form in our second step. So you will have an electrophilic species, and we are having the reduced DAD product. Both the hydrogens are attached on the place of the double bonds. And finally what happens? The nucleophile which is formed in the second step will get come and attack on the our alcohol, this electrophilic species ROPPH3. So we will have a product which is having the reverse configuration of the first the our OH group is present on the right hand side, and here it is present on the left hand side. So I hope this reaction is clear for you, and we will have the byproduct as our this dead, reduced dead, and phosphine oxide, and our nucleophilic product. I hope this is clear. So you can write both the reactions which I have shown in the beginning, as well as this reaction is also very important. So students, you can, if it is asked in the 1 mark, so you can write only this one reaction in the short, that alcohol and acids react to give the ester in the presence of two reagent, that is DAD and PPH3, and also you can write this reaction, that is our alcohols are getting converted to the respective product in the presence of our PPH3 and DAD. Thanks for watching. Do share with your friends.